Okay, good evening. What I want to look at is to look at motors. Now, I have put out a number of videos in regards to motors already and electrical machines. This is simply to support that information I have already given in regards to some of the videos. So you need to look at the electrical principles one for start and look at the playlist. Now, the playlist contains most of the videos you will need to look at and to read from. But remember, you do your additional research in support of the information you have been given. Okay, do not take it as read. Never do that. Okay, because new knowledge comes along, new information comes along, changes come about, and it shows us where we were and where we hope to be and where we're going to. Okay, so AC motors. Polyphase AC motors. Polyphase squirrel cage AC motors are basically constant speed machines. Okay, but some degree of flexibility in operating characteristics results from modifying the rotor slot design. So what we're saying here is that by changing the rotor slot design, we can change how the machine will behave or how the motor will behave. Okay? Now, these variations in AC motors produce changes in torque, current, and full load speed. Evolution and standardization have resulted in 4 fundamental types of AC motors. Now let me repeat that. 4 fundamental types of AC motors. Now, I'm not saying that there isn't other types, but the main fundamentals that we are going to be looking at and which applies to industry right across the world is within these boundaries here. Okay, but yes, variations of these type of motors can be constructed and be made for given purposes. And again, just to recap, evolution and standardization have resulted in 4 fundamental types of AC motors. The standardization, whether you're in India, China, Pakistan, United Kingdom, France, Belgium, those motors will be the same. The principle will exactly be the same. Admittedly, the voltage supply might be slightly different in some cases, but the motor itself will still be the same. Okay. The AC motors design A and B. Now, general purpose AC motors with normal starting torques and currents and low slip. Now, you need to have slip because if you don't have slip, then your motor isn't going anywhere. It's not going to be rotating. It's going to be standing still. And that is the slip which occurs between the rotational of the rotor and the magnetic field itself. Okay. Now, fractional horsepower polyphase AC motors are generally designed B because of the drooping characteristics of design B. A polyphase AC motor that produces the same breakdown maximum torque as a single-phase AC motor cannot attain the same speed, torque point for full load speed as a single-phase AC motor. Okay? So now what it's saying here, polyphase, 3-phase motors that produces a torque of a given value cannot attain the same speed torque point for full load speed as a single phase AC motor, which means that the single phase AC motor will run faster in this sense, but may not have the same torque as a 3-phase, which is a polyphase motor, okay, of a similar type. But again, do your own additional research. Look at the electrical principles booklets. See what they're saying. Look at the calculations when you come to be doing that. Okay, it is relevant to each point that we are trying to make. Now, therefore, breakdown torque must be higher, a minimum of 140% of the breakdown torque of single phase, a general purposes AC motor, so that full load speeds are comparable. So all you're saying here so that is that the breakdown torque of the motor will need to be 40% higher than its 100% operational value or speed. And if you consider that the breakdown torque, meaning that the motor may begin to stall at over a given load because it cannot operate or pull that load, then you're looking at this 40% value. Okay. Now again, do some additional reading. Okay, make sure that you understand the concept of what we're looking at in regards to breakdown torque. Okay. Now AC motors design C. Now again here, AC motors design C. High starting torque with normal starting current and low slip. Okay, so in your design C, you have a high starting torque with normal starting current and low slip. So this means that the torque, you can take maybe it can start up on the load. Okay, so that your motor can start on the load, allowing you to operate immediately. AC motors are normally used where breakaway loads are high at starting, but which normally run at rated full load and are not subject to high overload demands. Excuse me. After running speed has been reached. Now AC motors design D, high slip. It means that in regards to it has a higher percentage slip. AC motor starting torque, low starting current and low full load speed. Because of the high slip, speed can drop when fluctuating loads are encountered. So in this case, the speed is not constant. The speed can drop as the load changes in regards to the motor, so you'll get the motor kind of fluctuating, kind of imagine it being driving a belt, for instance, and that belt is shuddering on the load changes. Okay. This AC motor design is subdivided into several groups that vary according to slip or the shape of the speed torque curve. Now, when we look at the speed torque curve here, what we're saying is that I'm going to show you that later on. Okay, I'm not going to show you that just yet, and you can see how as you apply torque, the speed drops off. Okay, it just begins to drop off. Okay. The AC motor design F, low starting torque, low starting current and low slip. Now on average you normally have a 5% percentage slip, okay, roughly, but don't hold me to that because that can change depending on the type of motors you are working with. These AC motors are built to obtain low locked rotor current. Both locked rotor and breakdown torque are low. Normally, these AC motors are used where starting torque is low and where high overloads are not imposed after running speed is reached. It means that the motor will contain speed and will not run to its self-destruction. Okay, it will run to the point where it will maintain. Goodness me, I'm just thinking now if I've turned the volume up on my camera. Well, I'm gonna have to run in and see. Okay, so what one of the worst things you can do is actually be recording and forget to turn on the volume. Okay. Yeah, I know. Yeah, I know. I know. Don't say a word. Okay. Right, AC motors, basics of AC motor design engineering. Okay. And what I want you to bear in mind again, to work with this in conjunction with the electrical machines I've given you in the electrical principles and AC motors already. Okay, so look at those videos as well and bring them into play. Wound rotor AC motors, squirrel cage AC motors are relatively inflexible with regard to speed and torque. Okay, it means that the motor will run, once you switch on and it's a squirrel cage motor, it will run at that set criteria. It has no flexibility in its characteristics. But a special wound rotor AC motor has controllable speed and torque. Application of wound rotor AC motors is markedly different from squirrel cage AC motors because of the accessibility of the rotor circuit. Now, AC motor performance characteristics are obtained by inserting different values of resistance in the rotor circuit. Okay, now these resistance will be applied externally. So it will be like in a box where it will be then controlled, and it will be part of the motorized control system. Now again, do some additional research for yourself, and again, can I remind you please, safety, safety, safety. Now wound rotor AC motors are generally started with secondary resistance in the rotor circuit. The AC motor resistance is sequentially reduced to permit the motor to come up to speed. So as you push a button controls handle up, you're going through stages of resistance, and the motor begins to speed up slowly until it reaches maximum speed. It's like cranking up a car, but most of you will not know what it means to crank up a car, to start a car by crank. I do, okay? So ask your granddad what it was like to start a car by crank. Now, thus AC motors can develop substantial torque while limiting locked rotor current, okay? This secondary AC motor resistance can be designed for continuous service to dissipate heat produced by continuous operation at reduced speed. Frequent acceleration or acceleration at reduced speed, frequent acceleration or deceleration with a large inertia load. Okay, I will go at deceleration because I think that's an error missing there in regards to acceleration and deceleration. External resistance gives AC motors a characteristic that results in a large drop in revs per minute for a fairly small change in load. Okay. Now, reduced AC motor speed is provided down to about 50% rated speed, but efficiency is low. Multi-speed AC motors, consequent pole AC motors, are designed for one speed by physically reconnecting the leads. A 2-to-1 speed ratio can be obtained. Okay. Now, typical synchronous speed. Now, again, make sure you understand what synchronous means. Okay, look it up, do a search, look in your electrical principles books. For 60 Hz, AC motors are 3,600 to 1,800 revs per minute, 2 to 4 pole. And again, I've done a lot of this in motors and electrical principles, so look into that as well. You cannot just do this in 5 minutes. It is not a 5-minute job. You're not in the bedroom now. Okay, revs per minute, 4 to 8 pole, and 1,200 to 600 revs per minute, 6 to 12 pole. Now, if you're talking about 6 to 12 poles, look at the pairs. How many pairs? If it's a 6-pole motor, how many pairs would there be? It would be 3. If it's a 12-pole motor, how many pairs would there be? Be 6 pairs. Okay. It's all right. I was waiting for you to answer, but I forgot you can't hear me, so it's okay. 2 windings AC motors have 2 separate windings that can be wound for any number of poles so that other speed ratios can be obtained. However, ratios greater than 4 to 1 are impractical because of AC motor size and weight. Single-phase multi-speed AC motors are usually variable torque design, but constant torque and constant horsepower AC motors are available. Okay. Now, power output of multi-speed AC motors can be proportional to each different speed. These AC motors are designed with output horsepower. Capacity in accordance with one of the following load characteristics. Okay. Now I'm going to hold it there for a moment so you can make sure you can read it for yourselves, and that you can take the time to extract the information and for you to do some additional research. Now, I have not applied any questions in this case, but I may do that later on in its own right. Okay, so it will then be up to you to look back for this information, and I'll tell you where to find the information to answer the questions. Okay, so I will do that in due course. Okay, AC motors. AC motors, variable torque. AC motors have a speed torque characteristic that varies as the square of the speed. For example, let's say 1,800 revs, 900 revs per minute electrical motor that develops 10 horsepower at 1,800 revs produces 2.5 horsepower at 900 revs per minute. So in regards to from your maximum speed to your lowest speed, you can then see that the horsepower will be reduced. Now, if you're pulling a given load at 10 horsepower and you suddenly drop that load down from 10 horsepower down to 2.5 horsepower, what effect will it have on that motor? Just imagine for a moment, okay? You have a 10 horsepower load. It could be 2 tons, let's say for argument's sake. Suddenly you're going to be lifting 2 tons with the 2.5 horsepower. Will that motor do it, or is the motor going to be giving some issues? I will say the motor at 900 revs will begin to give you some issues. Okay? So you need to ensure that your motor can cope with the load at its respective speed of 1800 revs to 900 revs. So you do not put on a load that is greater than the motor can handle. Okay? And that is what he's trying to say here. Since AC motors face loads such as centrifugal pumps, fans and blowers have a torque requirement that varies as the square or cube of the speed, this AC motor characteristic is usually adequate. Okay. So you can see here that we're not lifting 2 tons as per my example, but we're simply using it to drive an air blower, a fan blower, or a hair dryer or something of the sort. So in these cases, it would not matter. But in my previous example, it would. Okay, page 4. Right, let me just go back a little bit, just make sure that I have everything in view. Okay, and that let me just see this for 1 second. Bear with me for a second. I will do it after. Okay. It's okay. Bear with me for a second. I just lost my direction. Okay, bear with me. Okay, right. AC motors constant torque. Right, and again here we're looking at AC motors constant torque. These AC motors can develop the same torque at each speed, thus power output varies directly with speed. For example, an AC motor rated at 10 horsepower at 1800 revs per minute produces 5 horsepower at 900 revs per minute. Okay, these AC motors. Oh goodness me, sorry. Good job. I can bring these back into play. Thank you. These AC motors are used in applications. Sorry about that. With constant torque requirements such as mixers, conveyors and compressors. Okay. The AC motors constant horsepower. These AC motors develop the same horsepower at each speed and the torque is inversely proportional to the speed. Typical applications for AC motors include machine tools such as drills, lathes and milling machines. Okay. Now again here we're just showing you where these motors can be applied and where they can be used and where they're most efficient and effective. Okay, Fractional horsepower types, all those single phase integral horsepower are available in the lower horsepower range. The most common fractional horsepower single phase AC motors are split phase, capacitor start, permanent split capacitor, and shaded pole. Now, you will have seen these in one of the videos I've already done in electrical principles and electrical machines. Look back at those, okay? They are relevant and they are tied in, connected. Use the information given. Now, the AC motors come in multi-speed types, but there is a practical limit to the number of speeds obtained. 2, 3, and 4-speed motors are available, and speed selection may be accomplished by consequent pole or 2-winding methods. Okay. Single-phase AC electric motors run in the direction in which they are started, and they are started in a predetermined direction according to the electrical connections or mechanical settings of the starting means. General purpose AC motors may be operated in either direction, but the standard AC motor rotation is counterclockwise when facing the end opposite the drive shaft. AC motors can be reconnected to reverse the direction of rotation. Okay, so this is not fixed, so we can change its direction by changing the electrical connections in the control box. Okay, what I want to do now is just to go back out to make sure that you have everything in sight and in view, and that I have not missed anything out. Okay. Now this will be done in sections, and I'm going to make a playlist for this work, because I'm going to put it into sections into the playlist area, and you will need to click into the playlist on my channel to actually find all the relevant pieces, because it's going to be done session by session. At this moment in time, I don't know how many sessions it will take to complete it, but I obviously will put all the sessions together so that they're in one place, so you can see that it follows through. I do not want pieces here, pieces there, okay? I want it as a sequential follow on from one another. Okay, I'm happy at that. Okay, so let me just go back down, and I'm just, excuse me while I make sure that I have all my pages in place and that I know where I'm going to stop. Okay, now this is session 1. Okay, and I repeat, this is session 1 of AC motors, various types and utilities. That's funny. That's funny. I thought. Oh, so sorry about that. My apologies. I'm not going there yet. Okay, this is where we're going to stop now, and that will be it for now. It's okay. We're just trying to figure out why something wasn't happening somewhere else. It's okay. Right. Thank you for now, and I will continue with this. Now you will need to follow on in regards to each session, okay? And I will put all the sessions in the playlist marked motors of various types and utilities. Okay, thank you. Have a good day. Bye bye.